Hello, everyone. In this chapter, we're going to take a look at some important formulas for elasticity. The first formula that we're going to look at is the price elasticity of demand. This is often annotated by E with a little d subscript. And this is equal to the change in quantity demanded divided by the percent change in price. Now, there are a lot of different ways you may see these formulas presented, and I'm going to go ahead and pop another example up on this slide now. This abbreviation of the formula means the exact same thing. So when we see this percent and then we have this triangle, that indicates the percent change, and then QD is quantity demanded, and the denominator is the percent change in the price. So either way that you see this formula written, it's going to go ahead and mean the same thing. Now, the first thing that we want to take a look at is actually calculating using this formula. So in this particular case, a university parking pass price increases by 50%, and as a result, 25% fewer people will purchase a parking pass. Let's go ahead and plug some numbers into this equation. So in this case, for our numerator, our percent change in the quantity demanded is minus 25%, and that's because 25% fewer people will purchase a parking pass. Our denominator, the percent change in price, is going to be plus 50% because we end up going up in price by 50%. When we divide negative 25 by 50%, we end up with negative 0.5 as our answer. So what does this numerical result of negative 0.5 mean? If the price of parking rises by 1%, the quantity demanded will fall by only 0.5%. Why is it negative? And that's just because the demand for parking is not very price elastic, and there is an inverse relationship between price and quantity demanded. So this tells me it will be decreasing, and this is telling me the percentage by which it will be decreasing. If we had received a positive result, then it would have been increasing by that particular percentage that was given. So let's do a practice question. Suppose that the price of candy bars increases by 100%. As a result of this, you decide to purchase 50% fewer candy bars. How would you describe your demand for candy bars? Remember that anytime that the elasticity of demand is less than -1, it's going to end up being elastic. If it is greater than -1, it's going to be inelastic or less elastic. In this particular example, you want to plug in for QD and our price. So you're going to have minus 50 for your QD numerator, and then plus 100 for your QD price. And whenever you do the math on your minus 50 divided by positive 100, you're going to end up with negative 0.5, meaning that your demand for these candy bars is not very elastic, or it is inelastic. There is one issue with our percent change formula. A price decrease from $100 to $80 is a 20% change, but price increases from $80 to $100 would be a 25% change. This would give us different answers in calculating our elasticity. Because of that, the midpoint method is a pretty popular way to calculate elasticity that corrects this problem. So in this particular equation, we're taking a look at elasticity of demand for the change in quantity demanded divided by the average of quantity demanded divided by the change in price divided by the average of the price. Now, keep in mind, if you're using a graphing calculator, everything in your numerator and everything in your denominator needs to stay in its respective parentheses. And if you're writing out formulas for your cheat sheet, then I would go ahead and tell you that this bottom formula is the exact same thing, but it's going ahead and writing out that formula for you so you can see it a little bit more visually. You can see that each color is going to line up with its respective calculation in the expanded version, and this will just kind of help you prepare as you're trying to get these written down and have everything together for working on studying for that exam. So an example, our old price or P1 is $6. Our old quantity is Q1, $15. The new price or P2 is $4 and our new quantity is 25. We then take these numbers and we want to plug into that midpoint formula for the elasticity of demand. And when we do that, this is what that looks like. I highly recommend pausing this video, making sure that you get the same things. When we abbreviate that, we can go ahead and solve, and we end up with negative 1.25. So when the price falls, quantity demanded rises, as we'd expect. We plug into the formula and make sure that you know where those are coming from. After you're able to solve this, you can see that this is less than negative 1, which means that this would be more of an elastic good. In this case, if demand is relatively elastic, we know that we're relatively sensitive to price changes and the demand curve will be flatter. If demand is relatively inelastic, we're very insensitive to price changes and the demand curve will be relatively steeper. We're going to take a look in the next few slides at what that looks like graphically. So if something is perfectly inelastic, then our demand curve is going to be completely vertical. Our numerator is 0. And there will be no change because this good is perfectly inelastic, and regardless of changes in price, our demand will stay the same. Perfectly inelastic goods will be things like insulin if you're a diabetic, or healthcare for a pet that you love very much. Now, relatively inelastic, in this case, that curve is going to be a little bit more curved. These are things like gasoline or cigarettes. And in that case, whenever we have adjustments, demand might change, but it's not going to change that much. The curve is flatter. If there's a large change in price, it's going to have a relatively small change in demand. Now, if a good is relatively elastic, like fruits, vegetables, breakfast cereals, there's a lot of substitutes available for these goods, and they may not be identical, but they're going to be close enough. So in this case, anytime that we have a change in price, a small change in price is going to cause a large decrease or a large change in demand because people will just seek out these alternatives. They won't pay that price. And then finally, the last thing that we're going to take a look at in this video is whenever we have something that is perfectly elastic. So perfectly elastic, it's going to have this horizontal demand line. And this is an extreme change. So anytime the price changes at all, demand will automatically go right to 0 because this is perfectly elastic. These are like grade A large eggs directly from a farmer, things that are a $10 bill. You know, if it's something that nobody's going to give you more than $10 for it. So if somebody tried to sell you a $10 bill for $11, you wouldn't want it. But if somebody wanted to trade you $10 for $10, you might be okay with that. This is where we're going to go ahead and stop this video for now, but you can head over to Canvas and take a look at the next one. Thank you. To Blackboard, rather. Thank you. Bye.